All right, guess who's faster? Is it Johnson or is it Green?
Green is faster.
All right, so, all right, I got one person who said Green. Is it Johnson or is it Green?
It's Johnson.
And I got one person. Okay, I got two people who said Johnson is faster. Okay, those of you guys who said Johnson is faster, what makes you think that Johnson is faster?
He covers more like ground, doesn't he?
He covers like more ground, doesn't he? All right, those of you guys who said anything at this point, give yourselves 2 points each. So who's faster? Wow, look at the numbers, guys. Who's faster? The guy who's moving faster than 23 or who's moving slower than 23? All right, so the short answer is Johnson is moving faster than 23. Green is under 23, so which means that Johnson is definitely faster, right? Okay, so at first glance, it looks like Johnson is faster. But then again, people will argue, and rightfully so, that they will say, wait a minute, if Johnson were faster, it would have had the world record in 100 meters as well. Green has the world record in 100 meters, not Johnson. And likewise, some people will argue that if Green is faster, how come he does not have the world record in 200 meters? All right, you can make the argument that the Green runs really fast 100 meters, but he doesn't keep up. His speed is not there. He gets fatigued after 100 meters. That's the reason why he doesn't have the world record for 200 meters. All right, so if that's the case, who's faster? Is it Johnson or is it Green? And all of a sudden you go, wow, it looks like Green may be faster because obviously, because he's faster in 100 meters. All right, notice that people make these kind of arguments. So is there any way to find out in terms of who's faster? Is it Green or is it Johnson, if that's the case? All right, guys, it is almost 9 o'clock, so I'm going to give you guys a 5-minute break. I need to get coffee, all right? And then I'll see you guys here in 5. Take a short little break, and then we will continue. All right, so who's faster? Is it Johnson or is it Green? Johnson is over 23 miles per hour. Green is under 23. So at first glance, you're thinking Johnson is faster. But Green has the world record for 100 meters. Johnson doesn't. So which means that Green is faster than Johnson in 100 meters. Does this mean that he's actually faster than Johnson in general? And all of a sudden, that something like this becomes debatable. And people dip the hell out of something like this. All right.
Speed.
To add to the confusion,
27 miles an hour.
NBC Nightly News says Green was running at 27 miles per hour.
As fast as an eagle flies. His shoes, size 10.5, a new design for greater power. Covered, no surprise, with stars of gold. Putting Green on a very fast track to Olympic gold.
NBC is no fake news.
Top speed.
But highly suspicious. His top speed, NBC says, referring to Green, is 27 miles per hour. And then they got this weird stuff like, hey, each step is 1/10 of a second on the ground. How would they know? 400 pounds. How would they know? Top speed, 27 miles per hour. How would they know?
27 miles an hour. As fast as an eagle flies.
Oh, they must have seen an eagle flying and matching speeds with Maurice Green.
His shoes, size 10.5.
Because eagles fly around 120 miles per hour. It's not 40 miles per hour. It's not 20 miles per hour. It's not 27 miles per hour. And all of a sudden, everything seems so made up. And then there's undue emphasis on the shoes, for God's sake. This is Nightly
New
News.
design for greater power.
Who cares?
Covered, no surprise, with stars of gold.
So they're almost trying to say that, hey, shoes are the ones capable of running at 27. So if you were in those shoes, you would also be able to run at this speed.
Putting Green on a very fast track to Olympic gold.
This being commercial TV, guys. What do you suppose the commercial that you will see right after this? Is that going to be a Coke commercial? Pepsi commercial. What do you think it's going to be about?
Shoes.
Shoes. There you go. Commercial TV. Fake news, not so much, but they try to sell products. One thing that we have to focus on, though, is Green. Was he running at 27 miles per hour at some point? And if he were running at 27 miles per hour at some point, because they said his top speed was 27, would that make him faster than Johnson? We'll find out. All right, let's play games at this point. So I'm going to show you how to do problems. Okay, formatting is where we are at right now. This is a creative project by one of the art students. It's a Godzilla problem. All right, so this is going to be problem number 3 from the handout. Go, go, go. Problem number 3. All right, so we will focus on problem number 3 and problem number 4 in terms of formatting. So we got the Godzilla running from the Japanese militia for an hour and a half. So we got the time. We'll cover 50 miles. So how fast was it running? So it's running for 1.5 hours, covering 50 miles. Question is, how fast was it running? All right, so next step is do the conversions. Hours to seconds, miles to meters. All right, so we will need to have the conversion factors. So miles to meters, meters per second to miles per hour. All right, so we'll have to go from hours to seconds. So 1 hour is going to be 3,600 seconds. We have to go from miles to meters. All right, so 1 mile is 1609 meters. All right, just remember to multiply the top and everything is divided by the denominator. All right, so we got our numbers in terms of the MKS unit system. So we got meters, we got seconds, no kilograms as yet. All right, so the formula for speed, measure distance over measure time. All right, so now we do, all right, evidently I made a mistake there, so I'll make a correction. All right, so distance over time is going to give us the speed in terms of the metric units. Converted to miles per hour is going to give us 33 miles per hour. Johnson at 23, Godzilla at 33. Johnson cannot catch Godzilla. All right, so that was a bit of a conversion exercise. So we did the conversion. So here I wanted you to see that you list everything first and then you do the conversion. So that was the purpose of this exercise. All right, so
if Godzilla ran from the Chicago police for 1.5 hours on Lakeshore Drive and he covered 50 miles, how fast was he running? Let's go to the film. Let's watch that one more time. Godzilla ran from the Chicago police for 1.5 hours and he covered 50 miles. How fast was he running?
all right, so this was a create project. Once again, guys, use the chat feature and put down your answers now. I need like at least 5. All right, I see a lot of C's. Awesome. Okay, 60 miles per hour represents speed. Give yourself 2 points for that one. Yeah, that's it. It represents speed. Give yourself 2 points for that. So moving forward. All right, so this is one more formatting exercise. So we got this MiG-28 traveling at the speed, which is 800 miles per hour, covering a distance of 155 miles. All right, so how long would it take? So how long would it take is our time. So T is going to be how long? 800 miles per hour is the speed. 155 miles is the distance. All right, so we want the time in terms of seconds. All right, once again, let's worry about conversions. Miles per hour to meters per second. Miles to meters. So the first thing you have to do is just always do the conversions to the metric units. All right, by the time the solutions that you're looking at right now, my lecture notes, I will make those available in the PDF form today. All right, so you can see how these things are done. All right, so we do a conversion miles per hour to meters per second, miles to meters. And then we'll express our answers in terms of the MKS unit system. Now the algebra. This time I want to show you how to do the algebra. Okay, so start off with the speed formula. All right, so I'm not going to let you guys use numbers when you do your algebra. So what you need to do is you have to do them symbolically. All right, so T needs to be isolated. Notice that T is in the denominator. So you can switch those two terms, just like that. So T goes up, E is going to come back down, and that's it. So that's the final format into which you put the numbers, substitute the numbers in metric units. So X, you will have to use the number in metric units for X. So it's this number. And for V, once again, you have to use, instead of miles per hour, use meters per second and that number. All right, so now you got a bit of a number crunching. All right, so you get a number which is very close to 700 seconds. Okay, we're done. As far as physics is concerned, we're done. As far as we're concerned, we're not. Okay, because 700 seconds doesn't mean anything to anyone. If you're in a relationship and if you're going to be late, you don't say to your girlfriend or boyfriend, hey, I'm going to be slightly late. I'm going to be there within the next 700 seconds. You don't talk to your friends like that. You don't talk to your parents like that. If you try, what's going to happen? somebody's going to dunk your ass. Your friends are going to avoid you. Your parents will try to disown you. All right, this sort of stuff doesn't work in real life. Only in the Big Bang Theory, someone like Sheldon can get away with it. In real life, you can't do that. So what do we have to do? We have to convert this to something we can understand. Convert it to minutes first, and check to see what happens. If it doesn't make sense, if the number is still too big, we'll just convert it to something else. All right. So we got 700 seconds converted to minutes. All right. I have to assume that you guys know something. You know that 1 minute is going to be 60 seconds. If you don't know that, just Google it. All right. So we'll do a conversion to minutes, and it's going to give you 11.64 minutes. That's about 12 minutes that you got. That's it. Now it's complete. Now this is something that we can actually interpret. So what that means is within 12 minutes at a speed of 800 miles per hour, you can cover 155 miles. All right, so this was more of an exercise in algebra.
We're at 155 miles.
To the extent ahead, closure 800 miles an hour.